Okay, and it's in two parts, in x and y. X basically stands for lambda, it's on the x-axis. You can see it starts from -2 and then goes up. And the y is for the value of the log likelihood. Well, if I enter b, that's no use to me, because what I'm trying to search for is the lambda that coincides with the maximum value of the likelihood. In other words, maximum value of likelihood is above -80. I want to find that associated value. This list needs to be sorted. Okay, so what we're going to do is the following. We're going to combine those two columns together and then sort them. So first I call lambda from beta, x in beta, call that lambda. The y we know is the likelihood, so call it lit like. Then we'll use a combine command to combine these two. Call it BC. To know what BC is, let's type in BC. You can see there should be side by side. There you go. Side by side. Lambda and likelihood. But they are not in order. If you scroll down, you can see that the likelihood is not in any order. So it's best to order, because otherwise you're going to be searching around here for a figure of likelihood above -80 to find the associated lambda, aren't you? To do this, we use the order command. So from this thing that I've created, I want to order by likelihood. I want it in ascending order, which is why I put the minus. If I don't put the minus, this will be in this will be in ascending order. If I don't put the minus, if I put it a minus, it will be in descending order. Put minus, it's in descending order in terms of the likelihood. So there you go. So we can see immediately that the likelihood is maximum as -76, and the lambda associated with that is 0.3, so that is the lambda I'm after. To see what I mean about the minus there, let's do it without the minus. You can see it's ordered now in ascending order by likelihood. In case you're asking me why am I ordering just by likelihood, not by lambda, it's because I'm looking for the lambda that's associated with the maximum value of the likelihood. That's why. Okay, so we've got an idea that lambda is 0.3. A value of 0.3, we can round that up to say it's approximately a third, so that suggests taking a cube root. Now we can actually do, at this stage, if we agree on a cube root, we just do this transformation volume. But if I wanted to use the exact formula in the Box-Cox, then it would be volume to the power of a third minus 1 over this thing, alright? But most practitioners will just kind of just do this. Let's see if it's had any impact on our pictures, our plots. So now we have a histogram like so, normality plot like this. Looking at these plots, it's not too great that I put them on one screen because they're kind of stretched out a bit. Okay, maybe that's better. Skewness, well, skewness before was positive, 0.3 something, wasn't it? And now it's gone negative, but it's much closer to 0. So it's suggesting that it's more symmetric now, the distribution of the residuals. We can also compare the residual plots from the first regression to the new one. Okay, this is the first one. Because I want to compare it, I want to open a new graphics window, so I don't want to get rid of that one I've just created. Okay, and there you go. Noticing that the residual plots I'm looking at are the standardized residuals, not just the raw residuals, for comparative reasons. Okay, so this is our first regression. This is the second regression. Look at it. Does it appear that if there was any hetero in here, maybe like that, this appears a lot more random and maybe in a band? You look at it and judge for yourself, okay? So by transforming by transforming by the cube root on the response variable, we've made the distribution of the residuals and hopefully hence the errors more symmetric. hopefully more normally distributed, and if there's any problems with hetero here, it should be alleviated as well. The original problem, there didn't appear to be any problems with non-linearity, and so there wasn't really an issue here. Although some of you might argue there is what's that, something, some kind of shape there. In any case, the dots here are completely random, so we're fine. And that's it for the Box-Cox transformation, doing a power transformation on the response variable.